Welcome grade 12s to STEM in Action's Boost series. I'm Vicky Guyan and today we're going to look at vertical projectile motion part 1. Right, before we get started, some knowledge that you should have from grade 10 and 11. You should know about our 4 equations of motion, and with that you should also know the quadratic formula from grade 11 maths. And we also know about the different graphs of motion that we learnt in grade 10. What is projectile motion? A projectile is an object upon which the only force acting is the force of gravity. Freefall is motion during which the only force acting is the force of gravity. If we have a look at our little picture there, we can see that whether you are dropping an object off a cliff or you're tossing something up and down, when that object is moving through the air, the only force acting on it is the force due to gravity, and so that is a projectile, and we are dealing with projectile motion in both those situations. Alright, acceleration. Remember that if we are talking about projectile motion, we've said that the only force acting is the force due to gravity, which means that the acceleration is the acceleration due to gravity, which is 9.8 meters per second squared down. It always acts down. Whether the object is moving up or down, gravitational acceleration is down. Projectiles that start with an initial velocity upwards will have a velocity of 0 when they get to their maximum height. You can see that in the little picture at the bottom. When we have objects that are thrown upwards, we also know that there is time symmetry. This means that the time from the initial height to the maximum height will equal the time from the maximum height back down to the initial height. Here we can see that the time it takes for the ball to go from his hand up to the top will equal the time it takes to go from the top back down to the height of his hand. We also have the magnitude of the velocity symmetry. So if we take the velocity at a certain point on the motion, the velocity will be equal in magnitude at that same point on the downward motion. Of course, it is the opposite in direction, so we need to make one positive and one negative. And there you can see in the picture, on the upward motion, if the velocity was v at this point here, on the downward motion, when it gets back to that point, it will still be v, but now it's in the opposite direction, so we say it is negative v. Remember that if we have a projectile from a moving object, the initial velocity of the projectile is the same as the velocity of that moving object. So here you can see in the picture there is a man in a hot air balloon. The hot air balloon is moving upwards with the velocity, and so when he drops the object from the hot air balloon, the object's initial velocity will be the same as the velocity of the hot air balloon. When it comes to our equations of motion, when we learnt about them in grade 10, when we dealt with equations of motion in grade 10, we dealt with them in a horizontal plane. Now we are moving to a vertical plane. So a couple of things that we need to be aware of. Acceleration is always the acceleration due to gravity, so it is always equal to 9.8 meters per second squared down. On top of that, our delta x, our displacement, sometimes may be displayed as delta y because it is now in the y direction. It is still displacement, and so we still calculate it the same way, but sometimes these equations will look a little different because we will substitute delta x over here with delta y there as well, and over here. In exams, you are allowed to use either version of delta y or delta x. Let's have a look at an application question from the November 2017 paper 1. We're going to have a look at question 3.1 to 3.3. Right, let's have a look at the November 2017 paper 1, question 3. Right, so the question says, stone A is projected vertically upwards at a speed of 12 meters per second from a height h above the ground. Ignore the effects of air resistance. 3.1. Calculate the time for stone A to reach its maximum height. All right, so we've got to work with the information that they've given. So we're going to read it again just to make sure we haven't missed anything. It's projected vertically upwards at a speed of 12 meters per second. So there we got our initial velocity from a height h above the ground. Calculate the time taken for stone A to reach its maximum height. So we're looking for time. So what I always do, we first got to write down what do we have. Well, we know that VI is equal to 12 meters per second. We are looking for the time. We also know that since it's going to its maximum height, at the maximum height, VF will be 0. And as always in acceleration, we know that acceleration is negative 9.8 meters per second squared. Notice that I'm taking upwards as positive, and that's why my acceleration is negative. Once we have this, we can go to our data sheet and we have a look at which of our equations are going to suit. We are looking for one that doesn't have delta x. That's the one that we're missing. So here we can see this first equation suits us. So that's what we're going to use. Vf is equal to Vi plus A delta t. We substitute in the values we have. Vf is 0. Vi is 12. Plus A is negative 9.8 delta t. And now we're simply going to solve for delta t. So we've got negative 9.8 delta t. So if I take this over, I'm going to have 9.8 delta t, because it was negative there, so it becomes positive, equals 12. Delta t is equal to 12 divided by 9.8. So we say 12 divided by 9.8. And we get 1,22 seconds. Remember, we can round off to our second decimal place, and so that's going to be a 2. Right, so that's question 3.1 answered. Let's have a look at the next question. Then says, at the same instant that stone A is projected upwards, stone B is thrown vertically downwards from the same height at an unknown speed v. Refer to the diagram below. And here's our diagram. We can see as A is thrown upwards, B is thrown downwards. When stone A reaches its maximum height, the speed of stone B is 3v. 3.2 says, calculate the speed v with which stone B is thrown downwards. Alright, so let's write down what information we have. We know that its initial velocity, from reading here, it said at the same instant stone A is projected upwards, stone B is thrown vertically downwards from the same height at an unknown speed v. So our initial velocity is v. When stone A reaches its maximum height, the speed of stone B is 3v. Okay, so our final velocity is 3v, but also that final velocity happens when stone A reaches its maximum height. So we also then know that the time to get to this final velocity is going to be the same time as it took stone A to reach its maximum height, which is what we calculated in our previous question. So we can use that. So question 3.2, we've got that time is equal to 1,22 seconds. We've got initial velocity, right? Remember, we've chosen up as positive. It was thrown down, so our initial velocity is negative v. Our final velocity is 3v, but it's still moving down, so it's negative 3v. And as always, our acceleration is negative 9.8 meters per second squared. And so yet again, we don't have delta x or delta y, so we're going to use the same equation of motion that we used before. Vf is equal to Vi plus A delta t. Vf is negative 3v. Vi is negative v plus negative 9.8 times delta t, which is 1,22. And so now we're going to do some calculating here. We're going to take the negative v over, so it's going to become plus v. So minus 3, you can even do this on your calculator, minus 3 plus 1, we're going to have minus 2v is equal to, and here we're going to do our little calculation, negative 9.8 times 1.22, and we get negative 11.956. Best not to round off here. This isn't our final answer, and we only want to round off at our final answer. So our final answer is what is V? So V is equal to, and we're going to take the answer we got there. So answer divided by negative 2, and we get 5,98 meters per second down. We know that V is down. Right, so that's 3.2 done. So there we've got our final answer of V equals 5,98 meters per second. Notice that they just asked for speed, so we don't need to worry about giving direction. Right, let's have a look at question 3.3. It then says, at the instant stone A passes its initial position on its way down, stone B hits the ground. 3.3, calculate the height h. Right, remember height h was where they were thrown from. So let's take this new information here. At the instant stone A passes its initial position on its way down, stone B hits the ground. Right, remember that the time it takes for stone A to get from its initial position to its maximum height will be the same as the time from maximum height back to initial position. We remember that we learned about time symmetry. So therefore we can get the time it took for that total motion. So our time is going to be equal to 1,22 times 2. And so we got 2,44 seconds for our total time. And that time is the same as the time it takes for stone A to hit the ground. So from its initial position to the ground. So from height h to the ground. So now we are going to work with stone B. We're going to say that our acceleration is negative 9.8 meters per second squared. I'm still working with down being negative, up being positive. All right. And our initial velocity for stone B, we now know, we've calculated in the previous question, was 5,98 meters per second down. And so because it's down, we should say it is negative 5,98 meters per second. And we want to know what is the distance it's covered. So we want to know delta y or delta x. We want to know the displacement that stone B has covered. Remember, VF is now not the 3V that we used in the previous question because that wasn't when it hit the ground. Right now we know it's now hit the ground, and so we don't know what VF is at this stage. So we've got to look for a new equation of motion. So we bring over our formula sheet, and we now do not have VF, so we're looking for the one that doesn't have VF, which here it is here. Okay, delta x or delta y, we're working with delta y, so let's stick with that. Equals VI delta t plus a half a delta t squared. And now we sub in our values that we know. VI is negative 5,98. Delta t is 2,44 plus a half a is negative 9,8, and delta t is 2,44, and don't forget your squared on the end there. And so we type all of this into our calculator. Include the brackets, that way you make sure you don't make any BODMAS mistakes. And so we get here negative 43,76 meters. Why are we getting negative? Remember, it's displacement, which is a vector. The displacement was downwards, and so that's why we're getting negative as an answer. But they didn't actually ask us for displacement, they asked us for h. And so h, the height, is just 43,76 meters. Height is not a vector, and so we don't need to have the direction there. Right, that brings us to the end of question 3.3. We're now going to have a look at another exam question. Right, let's have a look at an application question of November 2019, question 3. Right, so question 3 says, stone A is thrown vertically upwards with a speed of 10 meters per second from the edge of the roof of a 40-meter high building, as shown in the diagram below. Ignore the effects of air friction and take the ground as reference. Right, so question 3.1 asks us to define the term free fall. Question 3.1. Right, so we looked at the definition of free fall earlier, and it said that it is motion during which the only force acting is the force due to gravity. So let's write that down. Question 3.2 says calculate the maximum height above the ground reached by stone A. Right, so let's have a look at our scenario again. Stone A is thrown upwards from the edge of a building that is 40 meters high. So we can work out how high it goes above the building and then add in the building's height to get the height above the ground. So let's have a look. Our initial velocity is 10 meters per second. Our final velocity at its maximum height, remember when it reaches the maximum height, velocity is 0. Acceleration is negative 9.8 meters per second. Right, again I'm taking up as positive. And we want to know what is delta y or delta x. So we go and we have a look at our equations. We now do not have delta t, so we're looking for the formula that does not have delta t. Here it is over here. Vf squared equals Vi squared plus 2a delta x or delta y. So Vf squared equals Vi squared plus 2a delta y. Vf we said was 0. 0 squared equals Vi 10 squared plus 2a is negative 9,8 delta y. And so 0 squared is just 0. 10 squared is 100. Right. And then we're going to have 2 times 9.8, which is, and it's negative 9.8, so it's negative 19,6 delta y. Take the delta y over, so we've got 19,6 delta y is equal to 100, and so delta y is going to equal 100 divided by 19.6, and so we get 5,10 meters. Remember, we're rounding off to the second decimal place. If it's a 0, still write the 0 in so that we can see that you have rounded off to 2 decimal places. And then, but they didn't ask us for the delta y, they asked us the maximum height above the ground. So the height will be the 40 meters of the building plus the 5,10 meters it went above the building, and so 40 plus 5.1 is, well, I should say 10, is then 45,1 meters. That is the height above the ground reached by stone A. Right, let's have a look at question 3.3. Question 3.3 now says write down the Question 3.3 now says write down the magnitude and direction of the acceleration of stone A at this maximum height. Right, we know that at any point during projectile motion, our acceleration is the acceleration due to gravity. And so therefore, the magnitude is 9,8 meters per second squared, and the direction is always down. Doesn't matter where it is in the motion, that is always our acceleration for projectile motion. Right, let's have a look at question 3.4. it now says stone B is dropped from rest from the edge of the roof X seconds after stone A was thrown upwards. 3.4. Stone A passes stone B when the two stones are 29.74 meters above the ground. Calculate the value of X. Right, so we're going to have a look at each stone, stone A and stone B. Right, so stone A and stone B. This is for question 3.4. And we're going to write down what information we have for each of them. For stone A, we know that the initial velocity is 10 meters per second. We also know that our acceleration is negative 9.8 meters per second squared. Okay, so for delta y, we therefore need to take our final position, which is our 29.74, minus our initial position, which was the 40 meters above the ground. And so we're going to get 29.74 minus 40, and we get negative 10.26 meters. Why are we getting negative? Because it has moved down and we chose down as negative, so that is correct. And then remember, the question is asking us about time, so we need to then work out what is delta t. Alright, so let's start with that. Let's calculate our delta t for stone A. And so we're going to have a look. We do not have VF, so we are using this formula over here. Delta y is equal to VI delta t plus a half a delta t squared. And so we can substitute in what we have. We've got negative 10.26 for delta y. Initial velocity is 10. Our delta t is what we're looking for, plus a half. A is negative 9.8 delta t squared. And so here we can see the startings of a quadratic equation. And so we're going to get it into our standard format. We've got negative 10.26 is equal to 10 delta t minus, is a positive times a negative, is a negative minus 0.5 times 9.8, we get 4.9 delta t squared. So we need to rearrange this equation so that it's in our standard quadratic form, and so we're going to have 4.9 delta t squared. I've taken this over. Then I'm also going to bring this over, so it's minus 10 delta t, and then finally minus 10.26 is equal to 0. Alright, that's in our standard form. So now we know that delta t will equal negative b plus minus the square root of b squared minus 4ac, all of this over 2a. That's our quadratic formula. Normally we would say x is equal to, but x is not in our formula. We're looking for delta t. And so we substitute in negative b is negative 10, plus minus negative 10 squared, minus 4a is 4.9, c is negative 10.26, all of that is under the square root, all over 2a 4.9. Remember that a is the coefficient of our squared term, b is the coefficient of our t term, and c is our constant at the end there. Alright, and so we can then go and type this all into our calculator. Sorry, we've got to first do the fraction button. So we've got to roll over a fraction plus the square root 10 squared minus 4 times 4.9 times negative 10.26. All of that over 2 times 4.9. and we type it in, and so we get delta t is equal to 2,79. Remember there's a plus or a minus, so I've just done the plus. We must double check the minus, and we get negative 0,75. We can't have negative time, and so therefore that one does not is not a solution. So we'll write it down, but it cannot equal that, as we can't have negative time. Okay, so now we got our time for stone A. We now need to have a look at stone B. So I made space for it at the top, but I think we must just start afresh for stone B. So we'll just keep our answers for stone A there. We'll just keep our answers for stone A there, but we'll start afresh for stone B. Right, what do we know about stone B? Well, remember stone B was dropped from rest, so our initial velocity is 0. We also know that our acceleration is still going to be negative 9.8 meters per second squared. It's still a projectile. And we can also find our delta y for stone B. Stone B is dropped from the top of the building, so it's going to have the same displacement as stone A, which was the final, which is 29,74, minus the initial position, which was 40, the top of the building, and so we get negative 10,26 meters, right, which is correct. We're getting down, which we know we're on the right track, and we are looking for the time for stone B. All right, so we're going to have a look. Okay, so let's have a look. We'll start on a fresh page here. I'll just put this to one side. Okay, which formula again? Again, we are missing VF, so we're going to use our formula here at the top. And so we've got delta y is equal to VI delta t plus a half a delta t squared. Delta y is over here, negative 10,26. VI is 0 times delta t plus a half, a is negative 9,8 delta t squared. 0 times anything is 0, so that falls away. So we've got negative 10,26 is equal to a half times 9.8 is 4,9, negative 4,9 delta t squared. And so we're going to say negative 10.26 divided by negative 4.9, and we're going to get delta t squared is equal to 2,09, but it's squared, so we need to take the square root to get the answer, and so the square root of that, we get 1,44 seconds. We don't worry about the positive and negative square root because time is always positive. Now that is the total time that it took for stone B from its initial position to 29,74 meters above the ground. But remember that the question asks us to calculate x. Let's read the sentence again. It says stone B is dropped from rest from the edge of the roof x seconds after stone A was thrown upwards. So we're looking for the difference in time for stone A and stone B. And so x is going to equal 2,79 minus 1,44 equals, and we get 1,35 seconds. Right, that brings us to the end of question 3 from November 2019, and that also brings us to the end of Vertical Projectile Part 1. We'll see you next time for Part 2.